Whereas the third one, for example, might be a four-way machine instead of a single CPU, for example, or have 4 times the amount of memory or something like that. So, again, very, very similar situations, you would expect that fourth one to be able to handle 4 times the amount of traffic or whatever. We won't talk about the status thing until a little bit later on. But you will notice that what we're saying is that for this whole proxy set right here, what we're going to be doing is counting traffic. We're going to be counting the number of bytes in and out. And so, in this particular case right here, www3 would get 4 times the amount of traffic. Whatever number of hits that meant doesn't matter at all. It's counting the number of bytes in and the number of bytes out. Maybe it's got a larger pipe to the internet, whereas these guys are have a much more narrow pipe or something like that. So the ability to be able to tune the load balancing to the actual capability on the back end is very, very important. Now, I won't go into a lot of these details. If you want copies of the slides, I'm going to put them, on my website, which is just, www.apache.org/Jim. I'll put it on the main ASF site out there. I do that with all my slides, for example. But the main thing behind all this is that you need to know some things when you're an administrator. You need to know when backends have gone away. You need to know when backends have changed. You need to worry about sticky session support. Very, very important if you're using JBoss or Tomcat on the back end, where you need to maintain session affinity for these requests coming in. HTTP itself is a very stateless protocol. It was designed that way. It wasn't an oversight. It was designed specifically for that. But there are a lot of applications out there which it's easier for the applications themselves to work if they know that as this request goes in, the next request will be going to that exact same server rather than any other backend server out there. And so the backend application server needs to know that it's having this support for sessions, and the front-end web server who's doing load balancing needs to support that as well. And so Apache supports that. Most of them use cookies, which is basically an additional header in the HTTP request and response. People who are using Tomcat and JBoss are lucky because they get that for free. If you're using other technologies, you have to implement that yourself. You've got to force this session cookie into the actual request or response, at which point Apache and the server on the back end will keep those things going. Okay, so some of the things that we do have and do provide with these cluster sets, these balancers inside of Apache, is the whole set of failover. Obviously, it wouldn't be good to have, one of the reasons why you went to a clustered environment was because you didn't want to be dependent on, being in bad shape if the server went away. So being able to natively and invisibly handle when back-end servers inside of a cluster go away just comes along for the prize. You also have the concept of not only importance inside of a cluster, but several sets of clusters. You can actually have a hierarchy of clusters and nodes within that total environment. So you could have one cluster set which is all internal servers, cheap, you have full control over them and stuff like that, that's fine. If everything goes wrong with those, then maybe you have some co-located facility someplace. Then you want to then, and only then, transfer traffic to. Well, that would be a different cluster set. And then, for example, you had a different co-location facility that was overseas and would be dreadfully expensive for you to have to do that. That would be the cluster set of last resort. Well, the Apache configuration allows you to have these sets, these hierarchies of clusters out there. Okay, looks like I'm doing pretty good on time. So this is just another quick example of what this kind of looks like. So you can see that in the very, very top situation right here, we're basically defining 2 different cluster sets. That's what the LB set parameter is on the very, very bottom. The default is 0. So you'll see we're defending 2, and traffic will only go to the 2 offsite accounts, assuming that PHP 1 is down, PHP 2 is down, and PHP backup is down. And what's really nice is that we actually have this status on the very end of PHP backup. You see the status equals +H. That means it's a hot standby. So it's there ready to accept traffic, but Apache will not send any traffic to it unless PHP 1 is down and PHP 2 is down. So you see we have hierarchies inside of the actual cluster sets as well as hierarchies of cluster sets as well. Okay, this is another feature that we did have in 2.2 that has been significantly enhanced inside of 2.4, and it's an embedded administrator web interface that allows the admin of the reverse proxy to see what's going on inside of your web server. How much traffic is being handled? How many times has this particular node been elected? How much traffic has it seen? Stuff like that. And it also allows you to change some of these parameters on the fly. Now in 2.2, the amount of information you saw was pretty limited, and the amount of, or the number of factors, the number of configuration runtime factors that you could change was pretty small. You couldn't change, for example, the load balancing method. Whatever was done at the very beginning, that's what you were stuck with. You could change load balancing factors. You could maybe take one offline and online and stuff like that. So the amount of control was very, very, very limited inside there. And so this is the area which has really been driven a lot by cloud technology. And so what we've done with this user admin, which is as I said, a web app that Apache itself actually produces, is that you can, from this user administration interface, add new clusters, add new nodes on the back end. So as a new node comes online, you basically go to this web form, you click in the new name, you say add it, and Apache will immediately be aware of that back end, and once you turn it on, it'll start sending traffic that way. No need to do any kind of reconfiguration at all. Same thing with load balancing methods. That had not been something you could change before. Now you can. If for some reason the load balancing method that you were using doesn't work, or you hit some kind of strange kind of load and you want to go from buy traffic to buy requests, again, go to the web page, make the change, and Apache will immediately honor that change and go ahead with it. Also, any changes that you make via this web interface, if you so choose, can be persistent. So that way, when you take Apache down and then start it back up again, it'll not only go ahead and honor what was in the original configuration file, but it will see whatever changes you had made since that period of time and add those in again. Finally, all this is done in a pretty restful kind of interface. It's not completely restful yet. The previous one had been kind of a kludgy kind of way of setting it. But the idea behind it is that you can now drive this not just by a web form, for example, that you need someone to point and click through, but you can drive it through any kind of scripting language, for example. You can see how applicable this would be for the cloud. You can have some sort of entity, some sort of inventory manager inside of your infrastructure that says, oh, I see a new Tomcat went up. I'm going to go and send the command to Apache to say, oh, this is the new Tomcat. This is the load balancing factor for him. Add him in there. That's completely configuration free. It's completely dynamic in nature. You don't need to have an administrator inside that. In fact, in a plug for Red Hat, which as I said, I'm employed by, we will be announcing something in May at the JBall Summit, which leverages a lot of this technology that we're using inside of Apache inside here. Obviously, because you're doing sensitive stuff to the web server, you want to use the normal Apache ACL to protect this kind of, this web interface right here. And that's just a real quick little example. I'm pretty much out of time, but I do want to show you a couple of screen snaps. Apologize for the quality of that. I would have loved to do it in real time. But basically, let's just look right here what we're doing. This is just the admin that I referred to before. As you can tell, I did this as soon as the web server started up, so it hadn't sent any traffic. If I had waited and sent traffic through it, you would see like the number of times selected and the two froms be non-zero numbers. So let's just ignore that for now. But you can see that what I want to do right here is on the very, very last one, snap, crackle, and pop, which currently has a load factor of 1. You can see that I can change whatever load factor it is I want. I can, add, change the runtime. I can enable it. I can disable it. I can put it on a hot standby situation. I can cause it to drain, which is basically a flag to Apache that says, oh, if there's a session affinity going on to this back end, make sure requests get sent to there. Otherwise, take it offline. I'm going to gracefully turn this guy off instead of cutting them at the knees. So those are the parameters right here. In this part right here, I just clicked on the balancer foo URL, and I want to add another node to that historically 3-node cluster. I want to add another one right here. So you can see that not only can I change what the load balancing method is by this pull down, but at the very, very bottom where I typed in basically another URL that goes to the back end, I go type it in, hit submit, and then as soon as that happens, Apache is now aware of that. By default, once something is added, it's disabled, so it still requires the administrator or whatever controller is out there to go ahead and enable it. But that way, you can just make sure that it's set up correctly and stuff like that. Anyway, that is I'm way past my time. There's a lot more flexibility and freedom on being able to control these. I won't go through all of these, at all. But basically, the idea is that for something which is very, very old, for something which a lot of people consider old technology, a commodity technology, a software code base where nothing fun is going on anymore. It's kind of old, kind of stoic and stuff like that. Apache is again leveraged to it's already the #1 web server, by far, depending on whether you go to Security Space for their surveys or Netcraft or whoever. We really anticipate that with the with this improvement inside of Apache, as well as the usage of the cloud, that Apache will again continue. And what's really, really important, of course, is that a lot of this is based on feedback from people. So if you are an Apache user, definitely use it. We're in beta, as I said before. Download it, give it a try, give us any kind of feedback you want. We really want this to be as fine-tuned and as applicable to your environments as possible. One of the great things about conferences like this and times when I can talk to people is that, open source developers by nature don't have a very tight communication line to large enterprise level users. And so when you start seeing open source make those inroads to large heavyweight enterprise heavy duty usage environments, that feedback is very, very important. So, again, great things about this conference. If you do have any feedback, see me directly, on the mailing list or stuff like that. And I will just finish up by basically saying thank you.